probabilistic safety assessment, uh, a tool to estimate risk and drive safety improvements at a nuclear power plant. Um, when an NPP is designed, stringent requirements are imposed to make sure that all components can resist abnormal operating conditions. These conditions include severe weather, seismic activity, or intense heat and pressure that may occur as a result of an accident at the facility. This approach to designing the plant and its components using requirements and safety margins to account for potential abnormal conditions is called a deterministic safety analysis. And the probabilistic safety assessment was introduced in the 1980s, also to analyze overall risk to a nuclear power plant under abnormal conditions. Um, Level 1 PSA, which looks at severe core damage frequency. The safety goal limit is less than 1 time in 10,000. Um, for level 2, which looks at the large release frequency, the safety goal limit says 1 time in 100,000. Provide an estimate of the core damage frequency CDF, and identify the major accident sequences. Identify those components or plant systems whose unavailability significantly contribute to the core damage frequency. Rank the accident sequences and components according to their relative importance, and evaluate the planned operating experience. Evaluate the planned technical specification and limiting condition of operation. The first the first step in a probabilistic risk assessment is to identify a top event and trace out the different hazards that could lead to the event. System failures are identified and quantified by system models like fault tree, which deduce logical combination of simpler event. At the lowest level, the basic event of the fault tree are assigned probability distribution. This probability distribution are propagated up through the logic tree to reach a probability distribution of the top event. The response of the plant itself to each group of initiating event is usually modeled by the use of event tree.